here. Now let me see if I can share my screen out here. There we go. We'll do that one. All right. So, okay, there we go. So I think you guys are able to see me and the screen. Is that correct? All right, perfect. Okay, so a lot of what you do, I mean, it doesn't have to be, you don't have these microcontrollers necessarily. You can just do regular, electronics, all kinds of cool LEDs. But if you want to get a little fancy and a little bit more interactive with some projects that you're working on, you might want to think about using an Arduino. This is a basic Arduino Uno. Yeah, there you go. And they, you can get really simple with them or incredibly complex. So has anybody here worked with Arduino before? So what we can do is, to get started with them, it's very simple. You have to go to arduino.cc. Let me bring up that website. Let's go to Arduino here.cc, and you want to download the Arduino software. Now, right out of the box, it gives you the ability to work with a bunch of different types of boards, not just this one Arduino. But if you have something specific, I know the Textile Lab has a bunch of called circuit playgrounds. And so for different types of Arduinos, you might have to go through a different process to install them. But if it's made by Adafruit, or if it's just a regular, an Arduino, an actual Arduino here, they're real simple to get started with. And if you're on the Arduino website here, you can go to download the software here. And once you have the software installed, the place you want to check out here is the documentation. Tutorials, reference, and playgrounds. The tutorials have everything you need to get started with just blinking an LED. Or actually getting set up with the actual software yourself. But if you want to just blink an LED or use a button, and blinking LEDs and using a button is normally the basics I go through. But since we're not able to show off, all the stuff I have down here, we'll just kind of discuss and answer questions as they come in. But one of the best places to check out when you're working with your projects, and if you have different types of hardware, because we have people all over the world, it's hard to say what kind of hardware they have, but I know the Textile Lab, they have those Circuit Playground Kit. So if you want to get started with the Circuit Playground Kit, you can go to learn.adafruit.com. Adafruit is the manufacturer of the Circuit Playgrounds, and they have everything you would ever need to get started. So if I would type in Circuit Playground here, let's see, Circuit Playground. So here's the Circuit Playground Express that pops up. All right, and on the left-hand side here, you can see there's everything you need to know about, what the classic versus the Express version is, and the classic is an older version. So if you have one of these, you probably have the Express. Guided tours of what all the different components are on there, what they can do, USB, all the sensors that are built in, and everything you ever need to know about it, but also getting started with Arduino. And so this will help you get your Circuit Playground Express connected to the Arduino. And I'm going to go through that real fast because depending on what Arduino boards you might have, the process is usually pretty simple. It's the same, but complexity or simplicity depends on how well the manufacturer of the board has got it set up. So I'm going to click on my Arduino software over here, and I'm going to go to Tools up here, and over here to Board. Now I have all kinds of boards already installed. Now the AVR boards, they come with the Arduino software when you download it. So all these are already there. So if you can see, where's the Arduino Uno, which is the one I have right here. It's already right there for you. But if we want to use the Circuit Playground Express, now I come over here to Arduino, and I click on the Setup the Arduino IDE, and right here it tells you what you have to do. Install the SAMD software. So what we do here, and the instructions are all here, but I'm just going to go through them real fast so you know where the menus are and all that. We come here to Tools, and then go to Board, and then Boards Manager. All right, and let this load up. And we want to search for SAMD. That's the type of board or it's a processor rather, that the Circuit Playground Express has. So all we have to do is click on this right here and click Install. In fact, you can see all the boards it supports right here in the list. I'm not sure if you guys can read that. This text might be kind of small, but the last one here is Circuit Playground Express. So it's going to go through it could be a lengthy process, but to install everything. And not only do you get the ability for the computer to talk to the specific board, but you also get a bunch of example code. And that's one of the best things about working with Arduino. And we're just gonna let that run over here and kind of talk about more what's going on over here. So not only the learn area, so the reference over here on the Arduino CC website. It's great for all the different functions you can use. Playground is great for getting started with specific little tiny projects, input, output, and all that. So how to connect buttons and all that kind of stuff to it. YouTube is the best example, though. If you want to know how to do something specific, and if you're not able to ask me, and I'll be around, on and off throughout the evening and this weekend. But YouTube is a great example, a great resource rather. So that's how I learned everything with Arduino. Just go to YouTube, type in, blinking LED with an Arduino, and you're going to find a million, videos, of varying quality to show you how to do that. So that's, I think, probably the first example, the quickest example. But everything you need to know about it, Arduino is here. And then Learn also has Arduino, just general Arduino stuff, not specific stuff. So let's just say, we'll type in Arduino and see what we got here. There you go. Lady Ada, the lady who runs Adafruit, who's the owner of Adafruit, she's got a bunch of good Arduino Intro tutorials and just how to get started with the basics and all that. And I think she has 3 of these on there, and they're really, really well done. I'm talking about what they are exactly. And I guess we could backtrack just a little bit and talk about, while this is finished up the install, but what the Arduino is. The Arduino is you can think of it's a computer in the purest sense, but it's the controller on here is not a processor. It's referred to as a microcontroller. So it's like a very bare bones, very minimal, basic computer. It doesn't have any software installed on it when you get out of the box. There's no video output. There's nothing on there. The only thing that you get on there is what software code you upload to it. And as soon as this is finished here, we'll go through a quick process to show you how that's done. All right. But if you're working with, let's say, the Uno, you'll need a USB cable. Let me get mine ready here. And also, with the Arduino Uno board, you'll be covered pretty much whatever OS you're using. However, if you are using some very specialized board or some one-off board from some other manufacturer that doesn't have a lot of support, you might have to jump through some hoops, install drivers. We've encountered that in the past, people bringing in their own type of microcontrollers that aren't supported out of the box by Mac or Windows, and they have to go through a fairly lengthy process to install drivers. But in general, if you can, actually not in general, the rule of thumb is if you can get it through here, if you can get the board definition through here, everything you need to work with it is included already. So you shouldn't have to do anything else. But there's always the edge cases for newer versions of OS 10 or newer versions of Windows or older versions of both. All right, so that's finished up. So that's actually installed on the AMD board. So let's go through a real quick example and show you some of the things that you get, like I said, out of the box with the Arduino software. So I have my Arduino IDE over here, my window over here. I'm going to go up here to File. No, actually, I can't. Well, there, now it's done. So this is all finished. I'm going to close that. Now I can go up here to File, Examples, and I'll see a bunch of examples specific to the board that I have selected. Now, all these examples here say ESP8266, and that's a Wi-Fi version of the Arduino that I work with sometimes. If you go over to Tools and down to Board, you can see that's what I have selected right here. And I don't want to do that one right now. That one's a little more involved. So let's just stick with the basic Arduino Uno for right now. So I went to Tools and down to Board and selected, and then AVR boards and selected Arduino Uno. Now when I go to File, Examples, I get all these built-in basic examples, but then some that are more specific to the Arduino Uno. But the great place to start here is the basics. And we're going to go to Blink, which is the Hello World sketch of the Hello World program for the Arduino. When you're learning a new language, usually the first program that you write is called Hello World, so you can just make sure your program can talk to the computer to display something properly. But since the Arduino can't display anything, what we do here is basically have it blink a little LED that's built into it. So again, here's my Arduino Uno. I'm going to just plug it in with the USB. And you should see some lights come on. You should definitely see one right there called, it says on. It's labeled on, but it's green. All right, and that's the one we have right now. But what I'm going to do is now I have this Blink example sketch here. I'm going to upload it to the Arduino. Before I do that, I already have the board selected, the Uno, but I want to go over here to port and make sure that I have the correct port selected. And this is basically the USB port you have plugged in. And so if we come down here, the Unos all identify themselves on both Windows and Mac. So you should see some option down here that has Arduino Uno next to it, or even the Circuit Playground Express will also identify itself. So you should be able to just come up here and see in the list which one you need to select. It should be obvious. But once you have it selected, then you can click this little right arrow button up here, and we can hit that, and then we'll upload it. And it's gonna be kind of hard to see on camera, but so there's some lights that are blinking here to show you the upload progress. But now that we have it uploaded, you can see there's a little LED right there that blinks on and off. Can you guys everybody see that right there? I hope you can. All right, cool. And so what that's doing is that's actually what this program is doing right here. And it's turning an LED on. It's pausing the whole entire program for 1 whole second, turning the LED off, pausing the program for a second again, and then looping through. And that's a good, that's the basics of an actual sketch. So the programs in Arduino are referred to as sketches. So every sketch has these two main things at least. The setup right here and the loop right here. These are two functions built that you need to upload your software or your program to the Arduino. The setup one gets everything ready, and it runs the very first time you power on your Arduino, or if you hit reset, it runs first, and it gets things ready. And what it does here is it tells a specific pin on the Arduino, and these little areas here and here are referred to as pins because you can connect wires to them and then use them either on a breadboard or just directly plugged into some other device. But what it does is it gets it ready to be used as an output. So we want to be able to tell the Arduino that it needs to turn something on or off. And this LED built in, almost every Arduino has a built-in LED so that you can do this kind of testing to make sure everything works. And so in this case, for the Arduino Uno, the LED built in constant, which is what it's called, is set to the number 13. So if you can look right here, again, I know it's going to be hard to see. In fact, let me get a bigger picture of the Uno up here. It's not a very big picture. Come on. Okay, hopefully you guys can see that right there. So that LED that I was pointing out that was blinking has a little L next to it. And it's right next to the 13 right here. So actually that LED is connected right to pin 13 on the board here. And so that actually is number 13. So if I were to delete LED built in everywhere here, here, and up here, and just replace it with the number 13, it would work the same. But just kind of, it's a convenience thing for you, so you can just test out quick things like this. But again, when you run your sketch, you need a setup to tell it to turn that pin as an output so we can turn it on and off. And then once the setup is done running, everything it needs to get ready or do, it hits the loop. And the loop is essentially, it does what it kind of says. It just loops over and over and over. And as long as your Arduino has power and it's not being reset or anything, it just keeps going through the loop. And again, in this, we're just turning it on, pausing, turn it off, and pausing again. So yeah, we can see that it's flashing right there. So I'm just going to change this number here down to 250. So we're going to just pause for, instead of, oh, by the way, the 1,000 there is milliseconds. So 1,000 milliseconds in this case is 1 second. So I'm going to change it to 250, which is 1/4 of a second, so a quarter of a second. So when I re-upload that, hopefully you'll be able to see that we get some lights flashing, and then once they're done, that light flashes a lot faster now. The important thing to note, every time you make a change to the code up here, if you want it to be reflected or work on the Arduino, you do have to upload it. But once you have it uploaded, it's kind of referred to as being burned to the border here, burned to the chip. And so if you were to unplug it from here and then we plug it in again, we'll see that our changes will still take effect. And you'll see that a flash just as rapidly as it was before. So the code's already on here. So we can unplug this. These Unos have a little 9-volt battery connector. So you can plug a 9-volt into there and it'll run as though it were plugged into the power on the computer. So you don't have to have it tethered to your computer. And that's the nice thing about a lot of the newer Arduinos. They usually have built-in battery connectors. In fact, the Circuit Playground on Express, it's got, one side's got the USB, and the other side's got a little lithium-ion battery connector. So if you have a battery pack and it's charged, you can just plug it into here, and then whatever code you had on your Arduino, you can just run forever, as long as the battery stays charged. Those ones are really easy to run with like I said, with a battery, a rechargeable lithium battery. These ones, though, we carry a little bit more power, so you'd have to use a 9-volt battery pack for that. Or you can just leave it in plugged into the USB. That's one thing that I always like to stress with stuff like this, hackathons especially. But you're just prototyping right now. You don't have to have it battery powered. You don't have to have it wireless. As long as you can demonstrate what you're doing properly. And because we're doing this online, it's not like you have to walk across a stage or be in a big open room disconnected from power. So it'd be fine to leave it from powering from your computer or a wall source, and then just note that it could be battery powered with no problem. All right, so that's a lot, I think, for people who are new to this. So is there any questions so far that we want to stop and talk about before we move on to something else? All right. So what I'm going to do real quick is we've seen how to blink an LED, but I'm going to do one of the other basic things that I normally do is I'm going to show you how to use a button, because a lot of stuff that people want to do is interactive. And if you're not able to interact with the Arduino, you don't have that component. Oh, do you need any other? So other than the board, do you need any other materials? Well, it really depends on what you're looking to do. The board here, there's not. I mean, it's a bare board with the USB cable. There's not a lot it can do. It's really limited to blinking the LED. But if you wanted to, I'd say have a whole string of LEDs plugged into them, or have it control a servo or a motor of some sort, you would need the additional hardware to make that work. Yes. But do you have anything in mind that you were thinking of that you want to get a little bit more specific on? All right. So as far as the other materials, so like I said, the board here doesn't have any real easy way to connect your hardware to it. So a lot of times, if you're playing with the Arduino Uno, you'll have a breadboard that goes along with it. No problem. So if I wanted to say use an LED with the Arduino, my own LED, that not the one that's built in, I would need some wires. And I'm going to try to do this in a really awkward way by holding things up. Hopefully I don't drop anything. But I'm going to get some LEDs out. I'm a big fan of LEDs. I love LED projects. I have a whole bunch of different color LEDs here. They were super cheap, and they're also varying quality. Sometimes they'll just stop working or blow up a little bit, just a little bit, not dangerously. But so I'm gonna plug in. We'll just go with the blue one. Blue's a nice color. All right, and so what we do here to get this, I'm actually going to use the same sketch that's already on here, this blinking sketch, but I'm going to use my own Arduino or my own LED with it. So what I have here is a little blue LED. I don't know how well you guys can see that, but there's a long leg and a short leg. The long leg wants to be plugged into the positive power, and the short leg goes to ground or negative on the battery. So what I'm going to do is I'm going to have my Arduino and the LED. Now, the LED and my LED kit came with this really handy reference here. Each LED wants a different amount of power. So if you look at the blue wants 3.2 volts at most. But these Arduinos, which is not the case for everyone, but this Uno runs off of 5 volts, which is the same as the USB in your computer. And that's too much power, too much voltage to put through the Arduino. So normally what you want to do is get some resistors or get a resistor. So what I'm going to do is I'm going to put a 1,000 ohm resistor in with the LED. I know you're in here somewhere. And what that'll do is it'll help absorb some of the extra current and the extra power running through the LED so it doesn't get blown up. All right, and it's kind of, normally I would also demonstrate kind of how breadboards would work, but that's going to be kind of hard here, but maybe I'll pull up another picture. All right, okay, so let's talk about this real quick. There we go, so right there. So everyone can see that breadboard here. So I have a breadboard like this right there, a long one. This is a half breadboard, this is a full-size breadboard. And the way that these work is that the columns here, well, let's start here with these the red here and the blue here. It looks black, and it may be black, but usually it's red and blue. And I guess on mine, I don't even have, yeah, there's some blue. So the red and blue. So red and blue all the way across left to right in this picture, they're all connected. So the blue is all connected to the blue, and the red side's always connected to the red. And the same thing down here. The blue ones down here are all connected, and the red ones down here are all connected. But here, in the middle here, the columns are all connected. So the 5 pins running up and down in each column, they are all connected, but they're not connected left to right. And also they're not connected across this divide in the middle. So if there's a little divide right there in the middle and all that. So I have my LED kind of here plugged in, left to right in two different columns. But if I have it plugged in like this, up and down in one column, I don't know if you can see that, but it's called shorted out. Basically, the two legs are connected and it's not going to work. So most everything you'll plug in, unless you want to directly connect it to something, you want to keep it in separate columns. So here I want my LED connected to my resistor there. So you can see the LED leg is right there. So it's on this side right here. And then if you follow that column down, it's connected to the resistor there. All right, now I'm going to plug in some wires. And where we at? Okay. So let me pull this out to make sure again which side's left or which side's positive and negative. So the leg connected to the resistor is negative. So then we have a connection going from the long leg of the LED through the LED, down the breadboard, into the resistor, over to this column right here. I know it's hard to see it, and I apologize for that. But then I'm going to plug a wire into that. But I also want to plug a wire into the same column as the long leg of the LED. And depending on how much stuff you have going with the breadboard, it can get a little crazy, a little messy with all the wires. But this one, a little simple. But all right. So LED pin 13 on our Arduino is the one that we're turning on and off. So that's this LED built in. It's number 13. In fact, I'm going to just put 13 right there. 13. All right. And I'm going to plug this in and re-upload this code real fast. Now, in most cases, when you unplug the Arduino and plug it back in, you'll be okay. Though sometimes, and this is usually something I see on Windows, when you unplug and plug it back in, it won't automatically select the proper serial port. So you have to come back up here to the tools, go down to port, and then make sure you selected your Arduino in the list. All right, so because this is the negative side, the fires the negative side of the LED resistor circuit, I want to plug it into ground. And there's a couple grounds on the Arduino that you can see if you have an Uno, they're all labeled on the side here. But this side is going to go into the pin that we are turning on and off, and we have pin 13 up there. So if I flip it over, you can see all the numbers on the side. We got 13 right there. So if I plug it into 13, we should see our LED come to life. There we go. Now, if you can see there, the other built-in LED is still turning on. And this basically, because this is now just, this LED here is now connected in series, or sorry, in parallel with that pin 13 LEDs. Whenever the 13 gets turned on, the LED flashes, but also power goes to this pin 13 pin, or this pin 13 right there that we have plugged in right here. Now, if we want to change this to something else, let's say we can't use 13, or sometimes when I'm working on projects, I'll leave 13 unused so that I can use it later. So now I'm going to change this to 4 right here. I'm going to re-upload that. And when I do, you'll see it'll stop flashing and nothing's happening. But if I move the wire here from pin 13 over to pin 4, now we have our flashing LED again. All right, so we can use whatever pin we want, in general. Sometimes certain Arduino boards will not let you use certain pins for certain things. But if you're working with the Arduino, the pins 0 through 13 are all fair game, okay? All right, so that's all well and good, but how do we interact? Like, how do we maybe press a button, which I actually have right here, a little switch. How do we press that and make the LED turn on? Well, what I'm going to do is I'm going to take this switch, and I'm going to put it right across the divide here on my breadboard. All right, so I've pressed it down, flush with the board. It's really important, especially with these little components that have really, actually it's not flush, but they have small legs. So you want to get them down as far as possible, but you don't want to break anything. But with the breadboard and all that, it's pretty hard to break. So, all right, so I have 2 more wires. All right, and I'm going to go and unplug my Arduino. And it's best practice if you're going to be, reconfiguring the circuit you have for your Arduino, just unplug something so you don't accidentally short something out. Shorting something out is generally the case when you have the power coming from the Arduino, positive 5 volts, going directly to the ground on the Arduino. So whenever you don't have it going through a component or something else on the board, basically it's the shortest path for the circuit for all the electrons, the current to flow through. And so instead of going through everything else on the board, they'll prefer to go right to ground, and it'll be able to put so much current through, it'll shut the USB port off on your computer, and it generally will be okay. It won't, it's not catastrophic, but it could fry the Arduino. So you never want to directly connect the 5 volts power to ground. Or in this case, there's also a 3.3 volts right there. You don't want to connect that to ground either. All right, so now the way these switches work is there's 2 legs on this side and there's 2 legs on this side. And those are always connected on those 2 sides, but they are not connected across the divide. So whenever we press the button, it's going to connect these 2 legs to these 2 legs. So as long as we use one on either side, it doesn't really matter which one we use. And hopefully you guys can see, I know it's kind of small, but the legs coming out of the switch right there, going into the board, those little metal guys right there. And if you need me to slow down or stop and go over something again, please, by all means, throw it in the chat, and I will we'll go over it again. All right. Now, switches are a little different. I know most of the switches that we have in our homes, you turn them on, turn them off, and it basically connects power directly to the light. But in most electronic situations, unless you're just doing something with power delivery, what you really want to do is you want to be able to use the switch to trigger the Arduino to recognize something and then act upon that. So what we're going to do when we press the switch, we want our code essentially to check to see if we are indeed pressing the switch, and if we are, do something with that. So I'm going to come up here to File, New. Let me bring our new sketch up here. And let me jump the font up a little bit here. Hopefully that's a little easier to see. Let me know if you want me to make it bigger. But so yeah, we're not going to be directly connecting our switch to power. What we're actually going to do is plug our switch in one side into ground. So if you see, I have this side over here going over to the other ground on this side of the board, and on this side of the switch right here, I have it going over to pin 8 right there. It's upside down, but it's pin 8, trust me. And so what we're going to do is we're going to actually ask the Arduino, hey, is there something happening on pin 8? Now, normally when you think about switches, you turn a switch on, there's power going through it. But what we're going to do with this switch, and it's a little backwards, when you press the button on the switch, it's going to actually connect the pin 8 in this case to ground. And it's going to take all the charge that's on the pin and basically drain it all the way. So there's 0 volts on the pin. And when we're not pressing the switch, the Arduino is going to put 5 volts on that pin. So it's always going to be at 5 volts. 5 volts and 0 volts in computers, or any voltage in 0 volts or what have you. Those are called logic low and logic high. So 0 volts is low, 5 volts is high. And that's why we can see in the Arduino over here, we have low and high right there. So low you can think of as off, and high you can think about as on. Now, in the switch, though, what we're going to do is when we check to see if it's being pressed, we're checking to see if it's low. And if it's low, that means that we've pressed the button and we've connected that pin to ground, and there's no charge on anymore. And the best way to think about that is if you guys have ever played with the Van de Graaff generator. It's one of those big, metal balls you see at science centers that when you touch them, your hair sticks up. Well, if I had one behind my back and I was touching it, my hair would stick up, and you could see that. But if I let go of it, my hair would still stick up for a while until all the extra electrons in my hair on my body drain away to the ground. So if I were to touch it and let go of it, it really wouldn't be obvious what's happening. So what we do is we have some connection between me and ground. Let's say I have a metal table. I don't, but I could touch the power supply on my computer or touch my computer's case, and that would connect my body to the ground and the earth and the power system, power grid here. But all those electrons would have a way to go off from me somewhere else. And so what we do here is when we're not touching the button, a bunch of electrons build up on that pin 8, and the Arduino puts them there. But as soon as we touch that button, all those electrons can drain away to ground, and there's 0 volts. So the Arduino is certain at that point that there's either 0 volts to low or 5 volts high. Okay, and it's a little confusing, a little backwards, and there are a lot of really good YouTube videos to explain that. Before I fully understood that, back in the day when I was learning this, I watched like 3 or 4 YouTube videos before someone was able to explain it in a really good way. But it's one of those things where you kind of have to play with and all that to really wrap your head around it too. All right, so we have 2 pins. Now here I just use the number 4 directly, but what I'm going to do is instead of just using the numbers, I'm going to make a variable so we can store this. So if I want to switch this over here in our blank sketch from 4 to another pin, I have to go change it in 3 places. But what I can do is have a variable that is assigned the value 4, and then reference that variable in these 3 spots. And then whenever I want to make a change, I just change it in 1 spot. Okay. All right. So what I'm going to do here, I'm going to have a variable, and the variable, most everything in C, which is what the language is for the Arduino, has a type, and we have to give our variable a type, and we're going to give it the type int. And hopefully you can see that changes a slightly different color. It's not black. It's teal color, and it's a reserved word, so you can't use that in your own name, your own code. But the type is int, which is short for integer, and that's what we're dealing with here. We're just dealing with whole numbers, and so that'll be an integer. So I'm going to call this one LED pin. And I'm going to give it a value of 4. Put a semicolon after it. As a general rule of thumb, with a handful of exceptions, you want to put semicolons at the end of all your lines. But if you don't remember to do it, the thing will yell at you when you go to upload it, and I'll show you that in a second. And it'll be pretty clear what the problem is. So I also want to create another integer for the button, so that if I want to move it around somewhere later, I can. So I'm going to call it button pin. Now I plugged it into pin 8 on my Arduino, so I'm going to give it the value pin 8 right there. Now, just like over here, where we have to set up the pin to be used, we have to do that over here as well. And so what I'm going to do is say pin mode, and again, that turns a different special color, which means it's reserved. So it's a built-in function that the Arduino can use to set up the pin on the Arduino for something. So I'm going to say, we'll do LED pin, and we're going to say the LED pin is going to be an output. Then we're going to do the button pin. Now, the button pin is an input, but it's a special kind of input. So remember how I said that we wanted the Arduino to put 5 volts on the on the pin, so we know that it's not being used. So you have to use a special version of the input called input_pull up. And what it'll do is that means it's always going to keep the pin 8 at 5 volts until we press the button connected to ground, then it drains to 0 volts. And that's our way of always knowing one way or the other what's going on. Okay. All right. So now we're just going to loop in our code, and we're going to do something real super simple here, but it's going to demonstrate the input-output of the Arduino. So we've already got the output over here. We turn something on or turn something off. So the input, the way you do that, if we want to check to see if something's being pressed, we can have this. There's a built-in function, digital read. So over here, we did digital write, and that's on or off. Digital in computers is 0 or 1. And so we're saying either turn on or turn off this pin. So turn on or turn off this pin, and this is on or off. But here we want a digital read. We want to say, is this pin on or off? So what we're going to do here is a digital read, and we're going to read the button pin, in this case, button pin. So that's how you would digital read it, but that doesn't do anything. It just reads it, but we don't do anything with it. So we want to put this in an if statement that looks like this. If, and then in, get the parentheses right here, if digital read. So this is going to say if digital read, that means if it's on, which we're going to do, equals high. So if we read the button pin and it's high, basically we don't want to do anything. All right, so we're going to say do nothing. And what we have here with these 2 slashes and this gray text, dark gray text, these are called comments. So the code, the Arduino won't pay attention to these, it'll ignore it entirely. In fact, when you upload it, it doesn't get sent over to the Arduino at all. And then over here, we see these light gray comments that are, instead of just a slash, they're encompassed by a slash, asterisk, and then an asterisk slash. And that just lets you do a big chunk of code instead of a big chunk of notes instead of one line. So here, if the button pin is high, which means we're not pressing the button, we don't want to do anything. But, or else in this case, and this else is if it's low. So if it is low, we want to say digital write LED pin low. Sorry, LED pin high. All right. So what I'm going to do now is I want to upload this code. So I'm going to plug the Arduino in. I'm going to do a quick sniff test to make sure I didn't mess any wiring up to make sure nothing's burning. Because in general, if you do hook something up wrong or backwards, if your Mac or if your computer doesn't cut it off immediately because something's wrong, you'll smell a really distinctive plastic burning smell. And usually you have enough time to pull the power before something bad happens. And by bad, I mean nothing's going to blow up or catch on fire. It's just going to stop working. So, or sometimes things can get hot enough to where they can just give you a little burn. So just be careful. But like I said, you'll smell a very distinctive plastic burning smell, and then you just pull the power and you're okay. All right. So when I hit the upload, it's going to check all my code first and then upload it if everything's fine. So I'm going to hit upload. Here, it wants me to save it. So actually, I'm going to save it in my Arduino folder under LED Workshop, we'll say. And once I hit save, it's going to compile my code, and then we have an error. So here, if we look at the error, it says expected, and it might be hard to see that, but it's expected a semicolon before the curly brace token. All right, so then it says, here's where we found the error. So somewhere before this, it expects a semicolon, and you can see here I left my semicolon off right here. All right, so if I were to upload that, it uploads, then we have nothing's going on here. So what I'm going to do is I'm going to press this button and see what happens. So you guys can see that the light turned on, but it didn't turn off when I let go of the button. And that's because it is checking up here to see if we've let go of the LED. Sorry, let go of the button, but we said to do nothing. So we actually wanted to do not nothing. We want to turn off the LED if it's on. So we can come up here and just come and highlight this, copy. Oh, yeah. Copy, and then I'm going to erase this right here because we're not doing nothing, we're doing something. But instead of turning it on, we want to turn it off. I'm going to re-upload the code. And now it's done. Let's see what happens. So when I press the button, the LED comes on, and when I let go of the button, it turns off. So we have the input from the button and the output responding to that button press, the light being turned on and off. Okay, so that's, it's pretty simple, but I mean, if it's new, it's, could be completely Greek to you, who knows? So are there any questions about this code right here, or why I did something here and not did something there, or what this means or what that means? All right, so if questions come in, we'll just stop and answer them. Otherwise, what I'm going to do is what are we going to do? So I'm going to slightly modify this to make the LED stay on when we press the button and then turn off when we press it again. All right, that one's a little tricky. That one's a nice little project. One of my favorite things about that, because there's a whole like logical flow to how that works. And I watched live stream one time a few years ago with two experienced developers. They're JavaScript programmers. They've been writing web apps for years and years and years. And I watched them try to solve this problem for 45 minutes because they didn't want help from the chat and they weren't going to look it up. They just try to work it out themselves. And it's kind of it's a weird thing to think about. So right now, you press the button, turns on, you let go of it, turns off. So what we want to do here is press the button, it turns on, and press the button again, it turns off. So what we have to do in our code, because remember, this loop just happens every single time. All it's going to do is check for some event. In this case, it's going to check for our button to be pressed. And we already have that here. So what we want to do is whenever you press the button, which is, remember, it takes the pin low, that's when we want to do something. If you let go of it, we want to ignore it. Don't worry about it. But so instead of this digital pin equals high, we want to turn this to low. All right. And so here we had, if someone was pressing it, do something. If they let go of it, do something else. But in this case, we only care if they press the button. So actually, I'm going to get rid of this right here. So now if we press the button, we want to do something. But what do we want to do? We want to turn the LED on or off. But in order to tell which to turn it on or off, we have to know which state it's in. Is it on or is it off right now? So what we want to do is we want to create another variable. This one's going to be a Boolean. And a Boolean variable, a Boolean type is a true or false variable. This is either true or false. So we're going to say LED is on, and we're going to set it equal to false. When we first turn this on, turn the Arduino on, it's going to be set to false, as in the LED is not on. Okay, so here we say if the LED, or sorry, if the button is being pressed, we want to do something. Well, first we have to check to see if the LED is already on. So another if statement here. So if LED is on equals false. So if it's not on, we want to turn it on. The digital right LED pin high. Now the else for that is digital right LED pin low. So if the LED is on, sorry, if the LED is off, turn it on. Otherwise, turn it off. Okay. Let's see what that does when we upload it. All right, so let's see what happens. So nothing happens. It's always on at that point. And that's because what we're not doing here is we're not saying, we're not updating anything. So basically, LED is false is always false. So we have to, or sorry, LED is on is false is always false. So whenever we turn the LED on, we have to set that new value. So we'll say LED is on now equals true because we just turned it on. Conversely, if we've turned it off, we have to make sure to re-update that back to false so we can say it's off. So if we don't change this, this never changes either. It's always going to be false. All right, so there's that, and let's see what that does. So there, so it turns off sometimes. Sometimes it doesn't though. So that's unreliable. Now, what you're not seeing is when I press this button, I press the button down, it's going to go through and do everything here. But this thing is looping over probably in the order of 1,000,000 times a second. So what you're not able to see is it actually is turning the LED on and off, but it's so fast your eyes can't pick it up. So what we want to do is we don't want it to do it constantly. What we want to do is once you press the button, we want to ignore any other button press. We don't want to check it again if the button's being pressed until you've let go of it. So what we're going to do, when you press the button, we want to check to see if you were pressing it last time the program looped. So we need another Boolean up here. We're going to say bool button is pressed. No, button is pressed. It's going to be equal to true to false. When we first turn the program on or turn the Arduino on, it's going to be false. No one's pressing the button. So what we're going to do here, we're going to say, so check to see if the button was being pressed. But after the button's pressed, we're going to see if someone was already pressing the button. So we'll say if button is pressed is equal to false. So here we're going to say if nobody was pressing the button. That's what this is. If button is pressed is equal to false. We only want to do something if nobody was pressing the button last time. In fact, we need a double equals here. So if the button wasn't being pressed in the last loop of the program, then we'll do something. So what we're going to do is we're going to highlight all the stuff we did here for button flashing, and we're going to put it inside this if statement right here. I'm going to go through and reline this stuff up right here. So if you can see that high, that's kind of like organized a little bit, like everything's kind of indented in a little bit. That's not necessarily like super, it's not required, but it's kind of, it makes it easier to see what's going on. So I can say that this if statement is inside of this if statement, and this one's inside of this one. So it just makes it easier to read the code and understand what's going on. So while you don't need to, and it'll work just fine if you don't indent your code and all, best to do it so it's easier to, it's free to understand when you look back at it later. All right, so now we say if the button is pressed is equal to false, then we'll do this. Okay, let's see what that does. So I press the button, LED comes on, but it doesn't, oh, there it goes. So it's unreliable again, because what's happening here is, again, I didn't set the button was pressed back to true. So it's always false. So if the button was pressed, was false, the first thing I want to do is set button is pressed equal to true. Then go through and do the light switching thing right here. All right, so I'll run that again. So it's on. Now that we've updated the button is pressed to true, nothing happens anymore after I press the button again. because it's always true now. So it always ignores everything after that. So this is true on the second loop and never false again. So we don't ever do this stuff in here again. So I said it earlier, we only need to check to see if it's low, but now actually we have to check something else. We wanted to say if the button is pressed is equal to high. So this is the else here. So if it's not being pressed right here, sorry, if you're pressing it and it wasn't being pressed, that's fine. But down here, so if it's high, if you basically, it means that you let go of it. So this is if the button was pressed, and this is the else. If you can, it's kind of hard to see, but if you line it up with that if right there at the top, this is what happens if you let go of the button. So if you let go of the button, I'm going to say button is pressed is equal to false again. Remember, this else right here is what happens when you let go of the button, or when you're not pressing the button, rather. Then we'll set it back to false, and then it'll be able to do this next time. So let's see what that does. So now we have an on and off right there. Oh, there was a little issue there. So you'll see as I press this, it's not always super reliable. There you go. So there we go. And the reason for that is these buttons aren't super cheap. And a lot of buttons suffer from an issue like this. It's called debounce. So even though we're only pressing the button once every time, if you could zoom in and see what's happening on the very small scale of that button, you can see it's actually fluttering a little bit. It's not just going from not being pressed to press. There's like a little bit of bounce in there because of the springs and whatnot, or it slips and misses the contacts inside. So there are ways you can build a circuit around, it's called a debouncing circuit, so it ignores all those presses. But what we can do is as soon as you press the button, we can just delay the whole program, and usually about 50 milliseconds will work just fine. And that just gives the button enough time to settle, and either it's press state or it's unpressed state. So we're going to do that. Well, it's toggle switch in that. Oh yeah, yes. So like yeah, what's going on here? So we're just toggling a state on and off. Yes, that's what's going on. And instead of it being like a physical toggle switch, because and this is a momentary, it doesn't latch one side or the other. All of our code deals with keeping track of the state it should be in. In this case, which state the LED should be in every time you press it. Yes. And then it might seem overly complicated to do that, but a lot of times you're not going to easily be able to find press buttons that'll latch. They do make them. They're just called latching switches, and because normally a switch is an up and down if it's like that, but if it's a button you can tap, it's called momentary, just on or off. You just press it and let go of it, and it's off. But you guys, I'm sure you've all seen flashlights where you press the button on the flashlight and it latches, But those are a lot more expensive and they're usually a lot bigger too. So when you're dealing with electronics like this or smaller things, best to just do that in code, as opposed to, instead of buying this 3-cent button, buy like a $3 or $4 latching one. It's a lot bigger. But yes, it's a toggle situation now. Okay. Where are we at here? Oh yeah. So yeah, like I said, as you press it, like there's a bit of bounce, there's a bit of flutter in there on the contact, so it might trigger it over and over again. But if we give it a little delay there, that should be enough for my finger to settle fully down in there. So now that it's uploaded, now you can see it's pretty reliable. Now, if you really get in there, you start like really spamming the button right there, you might get it to freak out a little bit here or there. But in general, that's going to be pretty reliable. Now, depending on the Arduino or the button, you might still have an issue. It might not be super reliable, but you can always jump this up to 100. I've seen some real cheap buttons or just some real fast Arduinos that need you to jump it up a little bit farther. But even this is only 1/10 of a second, so a user is not really going to notice that slight delay. It's so fast. All right, so that's normally what I go through as far as like an intro to Arduino stuff. I know it was fast, and I know being remote, it's a little hard to pick up on. But any questions before we call it 5 o'clock here? No, maybe. All right, so even if there's no questions, I'll be back at around, I think 6:30. No, actually, I'll be back around 7, and I'll be on Slack, and I'll be in Hopin on and off throughout the evening. Probably going to call it a night about midnight, but until then, you're free to message me in Slack. I'll be here in front of my computer. I'll have my phone on me, and I'll do my best to drop in on the different sessions, different tables in Hopin. Okay? Any other questions? You're very welcome. And even though I won't be back until 7, you're free to send me a message in Slack, and I'll respond to it as soon as I get a chance to, okay? All right, well, good luck. Have fun. Bye, guys. See you later.